Okay, I will start now. Please type yes in the chat if my voice is clear to you.
Yes.
Okay, great. Hello, everyone. This is Adel. I'll be today's webinar moderator. I would like to welcome you to our 100th free webinar titled Directional Drilling, presented by our special instructor, Dr. Ali Farag. Dr. Ali Farag is a global advisor and SME for geomechanics based in Dubai. He started with Halliburton as a global DOS advisor, has over 33 years of operational experience. He is subject matter expert in directional drilling, geomechanics, drilling fluid engineering, and geology, as well as various management rules relating to real-time operations and support, and project management as the operation and exploration manager at an operator called Embed. And then a professor in British University in Egypt and Cairo University. Dr. Ali holds a PhD in applied geophysics from Ain Shams University and also a master in geopressure from Cairo University and bachelor's degree in geology and seismology from Zagazig University. The master thesis was about geologic control of geopressure pattern in Balaim oil field, Gulf of Suez in Egypt, and his PhD thesis was about geomechanical applications to optimize the drilling performance at Balaim land oil field, Gulf of Suez, Egypt. Such a great profile, but before we start our session, I'll make a small presentation about OPA. We will be conducting a live course titled Directional Drilling. It will be certified from IADC. It will only cost $250 only. The course will be presented by Dr. Ali Farag, the same instructor of today's webinar. You can scan this QR code to register. The course starts this Saturday, so make sure you enroll in it. It will be very beneficial. I can share the course content with you. You will also find it on the website page. We have also completed more than 50 courses that are now converted into recordings and available as recording sales in different disciplines like reservoir engineering, G&G, production technology, rig and rigless operations, data analytics and safety, and so on. Please note that these prices are before discount. And as we reach this milestone of 100 free online webinar by OPA, we want to celebrate this moment with you. So at the end of this webinar, I will share with you a coupon code for our flash discount that will only last for 2 hours. From the moment of announcement, you will get 85% on all our recorded courses. So thank you for sticking with us and thank you for being with OPA. Here's also one of our best services, which is OPA Mentorship Program. It's a one-to-one mentoring session by highly experienced mentors. It's like a tailored program based on the mentee's needs. You can request, explain the know-how of a software, guiding on personal data, professional guiding for PhD and master, helping undergrad students in their projects. We have already completed more than 45 mentorship programs with more than 900 learning hours, and the mentees were from more than 8 different countries. You can scan this QR code to register in our mentorship program. I will also share all the links on the chat after I end up my presentation. Here's a glance of our OPA website. It's www.opacourses.com, where you can access every single service of OPA, whether it's enrolling in recorded or live course, enrolling in our free webinars, enrolling in internship, mentorship, and so on. So make sure you pay it a visit. And finally, how to be an OPA ambassador. There are two tracks to join our OPA ambassadors community. Take one or more courses or just take a mentorship program. So what will you get from being an OPA ambassador? You will get more discounts on all courses in the future. Thank you for listening. And now it's time for our session. Engineer Ali, you can start your presentation now. Okay, we can see it.
So, Assalamu alaikum. Good afternoon, everybody. Do you hear me very well right now?
Yes, we can hear you well.
Okay, Adil, how can I move this down to hide this list?
Okay, you can hover over it and you will find like a minimize window or just drag it below.
Okay, right now it's okay. Okay. Today we have a short session regarding two-direction drilling overview. All of you, what we supposed to go right now, we'll talk about the direction drilling, what is the direction drilling is, how we can deviate the well, history, how we can measure the surveys in the well. Okay, introduction. What is the direction drilling? Direction drilling refers to practice of controlling the well trajectory well bore to reach a specific underground target that is not directly beneath the drilling. If you look for that small schematic one, we have the rig. I need to run. Okay, what we have here, we have the rig and then kickoff point. And kickoff point, at the point of the kickoff point, we're supposed to deviate the well. Was deviate the well, we build the inclinations 5.5 per 100 foot. The idea itself, okay, what doesn't work. Give me a second to use my pen. Okay, yes. What we have here, we have kickoff point. Kickoff point. That's point depend on the radius. All of that, the curve sections mainly depend on the radius of curvature. What the radius of curvature is. So if we have circle, in circle we have radius. In radius we have arc. And we have theta. So what we have arc equal theta multiplied by radius. So that one is in radiant. Well, but in the rig side, we are using inclination or angle. We cannot use radiant because the driller will not understand that. So what we'll do, we'll take that's 180, which this is 180, the pi divided by pi, which is 3.14, will give us almost something like 5,729. So the build-up rate supposed to be either degree per 30 meter or degree to 100 feet. So if we set build-up rate equal that number, which is 57.29 multiplied by 100 feet, it will give that number divided by R squared. Sometimes your client give you the build-up rate. He will ask you to build trajectory based on the build-up rate. What the build-up rate is, 3 degree or 2 degree or 2.5 degree per 100 foot. So we are using that one to give a radius of curvature. This is the radius of curvature, what we are looking for. So if we have this as radius of curvature, we build angle and we're doing a curve section, and then we'll do the tangent based on the build-up rate that we are got from our client. So to build that trajectory, first of all, you need the first build-up rate, then the tangent from that point to this point. This is the tangent, and then the second build-up rate, which is 10,000, 10 degree per 100 foot. So we'll come back again to build how to build the trajectory in details in our course. But right now, you're supposed to know what the build-up rate is. The build-up rate again equal, this is 157 by 29 by build-up by radius multiplied by 100 if we are using foot. If you are using the meter, that number 5729 multiplied by 30 meter. That's build-up rate by 30 meters. From where number came, that's one a conversion from a radian to inclination or angle, which is 180 divided by pi. That's as simple as that. Objective of direction drilling. Why we are doing direction drilling? First of all, we do site tracking. What the site track is, we are building the well while we are drilling. We got obstruction, we got the stuck pipe, we got what we got. And then when you are pulling out of hole, you cannot go. So you do a fishing, then I put cement and doing site track. So you got a deviation from the original hole, which is a vertical well, to deviated hole, and then you can come back again to your target. This is number one, or this is number one as objectives for direction drilling from number one. Number two, why we're doing a direction drill? We are controlling the fault. Why we are controlling the fault? If you have a fault like that, so we know that if you are drill like that through the fault zone, you will get a lot of trouble due to the losses, due to the stresses area. Then you will lose mud or you get stuck. So for that reason, we sometimes drilling, just crossing the fault using the direction drilling. This is number two. Number three, inaccessible area. Well, inaccessible area, you have a village. If you have a village like that, you cannot destroy this village to drill for that target. You stay here and then you're doing direction drilling. This one is inaccessible area. Or if you have rivers, if you have mountains, if you have some stuff like that. So the natural problems, you can access the straightforward the target from top to bottom, you do a direction drilling. Platform drilling, in offshore drilling, we have only one platform and we have many slots. And then based on that slots, you go for first well, second well, third well. That's one platform. That what we call it drilling on offshore. Okay. Salt dome deformation or salt dome drilling. Well, you know that salt coming and doing diabaric like that. When the salt come and doing diabaric like that, we have three stress regime. The first one, strike slip. From that one, we have reverse fault here, and we have normal fault there. Due to change between sigma 1, sigma 2, and sigma 3, which is sigma V and sigma H capital or sigma H small, or principal stresses. So to drill straightforward like that, that stress area, you cannot drill easily. Or if you go through the salt is it's contain a lot of temperature. So what we did, we stay here and then drill from far away as a direction drilling. So multilateral well, we stay there and we have one target. So we go and drill the target like that and like this. And if we have another target, we make a fishbone well, which is go from here to there and from here to there. Relief wells. I will take is what the relief well is. If we have catastrophic problem, like what happened in Syria a long time before 1998, there is blowout, and that blowout, a lot of hydrocarbon come into the surface, and they cannot control the well. and the well start burning, what we do something, we call it relief well. We stay far away from this location and drill well to kill what we need to kill. We have a reservoir at that point, and we have a well, and that well got a fire due to the catastrophic. So we are staying at that point here and doing relief well, maybe more than relief well, 2 or 3, to kill the well and to control this well. Why we call it a relief well? Horizontal drilling, if you have a thin bed, so you can go for horizontal drilling easily in each direction. Okay. Onshore, offshore drilling. Sometimes, like in Egypt, in Aberdeen, there is island, and this island very close to shoreline. We put an island, we put some land rig here, and we can drill inside the sea or inside the ocean or inside the onshore, offshore. Why that? Because land rig is very cheap comparing to the rig on offshore. So geosteering, sometimes we have a very thin bed, so we can go as far as we can. So we're using a geosteering technique. Is shape well if we have 2 wells. So that 2 wells we have, or 2 targets, sorry, we have 2 targets. We can build inclination, come from here to there and build inclination, hold inclination, and a drop that we call that S-shape drilling. So really a lot of objectives related to direction drilling. Direction drilling is starting 1930s, first attempt to do direction drilling because they would need to doing sidetrack. And after that, we control the lease. The lease, we're drilling at that point. We cannot go out from the boundary of our lease. So they're doing a direction drilling to correct the well as a correction run. And they used acid bottle for a surveying method. This was very basic tool. We have acid and bottle like that and drop it in a well. When you drop in a well, the acid will take the verticality, so we can know where is what is the inclination of the well. 1970 to 8 raise a measurement well drilling, which is MWD. That's almost about 50 years before. Before that, we are using a single shot. We're using Totco ring or Totco on acid bottles. Present day, we have RSS, was a rotary steerable system to do 3D well placement. That's one to replacing the motor in most cases, and that's one help us to avoid the K-seats and high dog leg and tortuosity. What the tortuosity is a summation from dog leg from 0 to TD. That's what we call it unwanted dog leg. So the RSS help us to control the dog leg and tortuosity. How it's come, so if we are doing a summation for dog leg like that, and we have calculated or actual dog leg, it's coming like that. So that's one unwanted dog leg. We not need this is unwanted dog leg. The rotary steerable system help us to do very smooth wellbore trajectory. Type of direction drilling. We have 3 types of direction drilling, by the way. I would like to mention that. The first one, we call it G-shape. G-shape. I will come back to that one based on the radius of curvature. And we have S-shape, and we have double belt. Double belt. Double belt, it's horizontal. We have 2 types of G-shape. Why? That because we have a relationship between the radius of curvature and target distance. So when is the target distance, which is R, bigger than the distance, this is one type, and R less than the distance, target distance, this is another type, 2 type. How it's coming like that? If you have a rig here, kickoff point, your radius, and then go down to TD, and then you have a target distance, And this one is a part of angle, and then this is your curve, and this is your tangent. This is our shape of the well, that one. So that we call it G shape. The other one, when the radius itself bigger than the distance, so the radius of curvature is very big, very, very big. And then, sorry, there, I will erase it to keep it clean for you guys. Okay, here we are. When the radius kickoff point, and then the radius bigger than the distance, so that one is very big. So I will do the tangent. So that's one, it will be like that. Kickoff point, curve section, and then tangent. That's one is, so the build-up rate here, it's very, very small. So this shape, it could be built to inclinations, kickoff point, built to inclination, and then hold, and then it drop to zero, or kickoff point, built to inclination, and hold, and drop to angle. This is angle maybe 20, 21, 40, what that doesn't matter. Then this shape itself, we have two types. The first one, build from the kickoff point and tangent, and then build until becoming horizontal, which is 90 degree. Or if you have a bedding with 2 degree minus 90, it will be 88. Either at the end, build to 90 or build to 90. 88 due to the bedding of or tilting of the stratum. What the kickoff depths? That the depths where we are moving from 0 to degree, where we are deviated the well from verticality. Okay, what the radius? We told that that's one is a big radius well, or what we call it, that's short radius, short radius, and there is ultra short radius and medium radius, and that's one large radius or long radius. What the long area based on the circle itself. That curve section is a part of circle. This is one is a part of circle. When the radius more than 1,000, we call it long radius. When the radius is 300 feet, we call it medium radius. When it's from 2 to 6 feet, we call it a short radius well. And there is some ultra short radius well when the inclination coming to 70 or 75 or sometimes 100 degree per 100 foot. I drill one well like that in Qatar. It's very ultra short radius well. I did all the direction well in few hours in one drill. So what I like, what's planning is, if you have a trajectory already and you decided my trajectory is a short or long or medium radius based on the build-up rate. Okay, then what is the target? We have three targets based on the person. And directional, the original geological target is very big, as you see the green one. We do some uncertainty for that to reduce the target for geo uncertainty. We call it geo uncertainty based on the geologist. Reduce it for drilling uncertainty to keep yourself in that red area. We call that one as a drilling uncertainty. So the drilling uncertainty, you need to build your well plan based on subsurface, surface location, subsurface location, coordinate X and Y, through vertical depths, measured depths, and then after that you need to build your trajectory, either build hold, build drop, G shape, S shape, and so on. And then you need to think about the anti-collision. What the anti-collision is? The distance between one well and another well, because you are traveling inside the earth. If you're coming very close to that well, you can go ahead and collide this as well. And then if this is well producing, you will have a lot of issue, a lot of problem. And that one, it will doing a catastrophic. Then you need to do a torque and drag analysis model. I will not go for this today because there's a very big issue. Both of them are very big issue. So what I would like to give you today, I would like to give you an idea about the directional drilling. So surveying tool methods, we have three types of survey. Magnetic single shot, that's starting from the beginning, that's one. It's giving, as you see here, it's a kind of disc, and that disc you have bin, and this bin you drop it inside the hole. It's giving you where it is exactly the inclination and direction based on that one. And then we have gyro. Gyro, it's important for us to build traveling cylinder in anti-collision because we have a very good confidence, and we have a confidence level in gyro more than the other tool. Why that? That because the gyro itself is not affected by magnetic. A magnet is coming either from a drill string or coming from surrounding area. So we consider gyro, it's a definitive survey. What the definitive survey is, the trustable survey. We have a survey from MWD, LWD, or magnetic single shot. We'll take a gyro to build our traveling cylinder around the well to avoid any collide or for a close approach purpose. The measurement while drilling MWD starting, it's almost, it's very, very, very recent. It's coming from 1985 or around 1985. So it's three sensors, magnetometer and accelerometer. The MWD gave a three reading. The first one, we call it tool face. What the tool face is, that's what I'm using for sliding and rotating mode. The second thing is inclination. And third thing is azimuth. And from the tally book, we got the measured depths. So from measured depths, inclination and azimuth, I will go ahead and calculate what I need to calculate, like TVD, true vertical depths. I need to calculate horizontal displacement, what we call vertical section. What the vertical section is, we calculate that next course, inshallah, when we have north, south, east, west, and this is my plan. So the vertical section is projection from the last survey and plan of proposal. Then each survey you got it, you do projection and plan of proposal. See, that's your target. This is my plan of proposal direction. Then each time you got survey, you do projection, what we call it a vertical section. So based on what? Based on the MWD measurement. And we correct if we have two surveys, one coming from MWD, the other one coming from gyro, I will accept gyro. Why that? Because there is no magnetic interference. Okay, survey calculation terminology that already I did. Inclination angles, which is coming from the vertical. Azimuth, we know the azimuth, that's one the maximum from 0 to 90. That's one from 0 to 360. And true vertical depths, if you take it from sine cosine rule, this is true vertical depths, and that's one is measured depths. The true vertical depths depend on the datum itself. We have three datums we are using in the oil field. The first one we call RKB, we will call rotary Kelly bushing. That's for driller. If you have the rig like that, this is the rig. That's one RKB or Kelly bushing based on. That's one is wellhead from the ground level. That's one for production engineer. And then you have a C bed, that's C bed, and here is C, that means sea level. In sea level, this is one for seismologists or geophysicists and using for geologists. For that reason, sometimes you have TVD subsea, and almost it's coming by negative. So that's the reference we have. How many reference we have? We have RKB, again. We have main sea level. We have ground level, which is very close, and we have a wellhead. This is 4 references. We are use that in the oil field. Wellbore departure methods, earlier we used that jetting methods. What the jetting methods is, Before we got the motor, before RSS, we're using a jetting in very soft formation. As you have here, we have a bits. In the bit, we close all the jets and keep only one jets, and we're doing scribe line and start jetting in one directions, and that's one is doing, as you see here, it's doing kickoff. That's one we did it at the service whenever we have a very soft formation like shale. We have a web stock as well. Web stock, that's pen, we share the pen, and we have milling assembly as you see. When we have the casing, we need to mill the casing to open window. We put the web stock, and then we'll start milling the casing to do windows inside the casing, and then we'll go out like that. So that's web stock as well, as you see. That's web stock. That's web stock. It could be in the casing or could be inside the formations, and that's technique. It's really a good technique to do in sidetrack, saving a lot of time, and instead doing time drill. Sometimes we're doing a time drill. Anyway, drive system to doing a wellbore departures. Let's go for it. We have two drive services. We have two drive systems. One on the surface, another one downhole. What on the surface? We have a Kelly bushing, rotary table, and Kelly, and nobody used that one so far. Why that? Because it's not saving time. Everybody going for top drive. Why the top drive? Top drive using a stand. What stand is? Three pipes together. What three pipe together? We call it stand. You drill by stand. This one drill by single by single, pipe by pipe, which is 9 meter plus or minus. That's one is the 30 meter plus or minus. So that's what we have. So what also the benefit for top drive is doing a back reaming. We cannot do back reaming with the Kelly. We can do that. If we have difficulty to drill or getting out from the hole, we can use that top drive. Okay. So downhole we have BDM. What the BDM is? Positive displacement motor. What the positive displacement motor is? That one is transferred the hydraulic power to mechanical power, and then we use the motor to do slide and rotate. When we're doing slide and rotate, we are building our trajectory based on according to the plan. Turbine is the same, but the turbine there is no bend. There is fixed bend. You can put the bent housing, fixed bent out 0.5, 1.5, and so. But the BDM is adjustable motor. Well, there is a different technique between both of them. We have a rotor and stator and power section, and what we call it power section and BDM. But that's one we have some stages like turbine stage. And then the RSS came. We have two types of RSS. The first one is the pushing system. The other one is the pointing system. And everybody using right now the RSS in addition to motorized RSS. And that it's really a very big issue. So that the motor, as you see, we have a power section, rotor and stator, and we have some configuration of the motor. What the configuration of the motor? One, we have one that's one we call rotor. That's one is a stator. We have 1 to 2. There is 2 stator and 1 rotor. This is very, very fast, but the output torque is very exactly like the gearbox of the car. When you have a gearbox of the car, the big one, which is the first one, you have a very high output torque. At the same time, it's very low speed. So like this is one. That's one high torque, but very low speed because it's 9 to 10, 9 stator to which that man here with the power sections. It's 9 to 10, 9 stator to 9 rotor to 10 stator. This is 7, 8, 5, 6. Also, most people, that's power section assembly for BDC. BDC, we need more torque, more output torque rather than the RPM. But Tricon bit here is need more RPM instead or rather than the output torque. So if I have Tricon bit, I need to select the configuration of this motor to be 1, 2, or a 3, 4. The output torque on the motor depends on the length of the bar section. Sometimes we call it tandem, and depend on the number of the loop configurations. Is that 9, 10, or 7, or 8, or 5, 8, and so on. So this is the power section. After the power section, we have adjustable bent housing from 0.5 degree sometimes to 3 degree. You can configure this is bent housing when you got that 1.5 to 1.5. You have a bending 1.5 degree, then you can start doing scribe line here, and you can start sliding until you are building your. So that's one is the rotating box. That's only that part will rotate when you're bumping drilling fluid from here. The rotor will transmit the hydraulic power to mechanical power through the mechanical assembly here or drive shaft, and then it will go straight forward to a rotating box. That why we call it PDM, positive displacement motor. Advantage of this one is the low cost and very simple to build your inclinations. So we have also turbine. This is turbine, it's stages, and that stages you pumping the fluid, that stages convert the hydraulic power to mechanical power. You have a bit here. The only things of that turbine is give a very high RPM, but it's not has adjustable bent housing, so you can use only fixed bent housings 0.5, 0.3, and so on. So then the rotary steerable assembly coming, and we have 2 points, two type. The first one is the bushing system. That's bad when you are drilling with hydraulic. It consists from 3 parts. The first part is electronic part, and the second one is mechanical part, and then you have an electronic part, they call it bias in Schlumberger, I think, and that's one is the box. You are doing a trajectory while you are rotating because you have a map, and that map you give, I need to build inclination with drilling cycle 5 minutes. So in 5 minutes, you put your tool face. What the tool face is? Tool face is the direction where you will slide or rotate. So that's one is 0, 90 to 70, and that one it will be, sorry, 180 and 270. Okay, from 0, we have build at that. If I put the tool face in the map in the 0, it's well build mainly. So that's one is turn right. In between that one, build and turn right. Build plus turn right. Okay, and that's one low side, and this is high side. 90 turn right, and then here drop inclination plus turn right. Okay, and then 180 here completely drop inclination. So that point here you can drop plus turn left. Okay, what that one? This is turn left completely, and this is one build, and here build and turn left plus turn left. Okay, what does it mean? Does it mean if I have inclination in the well 90, and say I have inclination 45, and I have azimuth 30. Okay, I need to build inclinations and at the same time turn to the right. So fine, I put myself here. I will, next survey, I'll find my inclination 42, and I'll find my 30 as the azimuth. This is azimuth, this is inclination. It will be, say, 50, some stuff like that. Fine, good. So if you need to turn left, that one, you need to turn it to the left, and you need to drop, fine. I'll put it here, turn to the left and drop. I'll put myself at that point here between 180 and 270. Then that's 40. It will be, say, 35 as inclination. And this is 30. It could be 25 because you turning to the left as per our setting. That setting depend on the drilling cycle and tool face. What drilling cycle? Some companies put drilling cycle 3 minutes, and some people said 5 minutes. Okay, I'll put the tool face. Okay, I bought some stuff like 30 right, that's the tool face, put it in the 30 right at that point here, and doing drilling cycle as 70%. 70% out of 3 or 5 minutes, it's well doing sliding, and the other 30% in neutral mode. So otherwise, if you keep it for 5 minutes as the setting, it will be doing a very high dog leg, or maybe you will, if your required build up rate 3 degree, maybe you will get 4.5 degree, which is too much while you are sliding. So that's one is the bushing system, but that guy is pointing. Pointing, that's mean you have to access, there is offset between the main body and the axis of that one. And this is part rotating with a different RPM of color rotating. So it's doing bending, doing like pointing system exactly as we did in drilling by using a motor or sliding and rotating move. So then after that, you need sometimes the company man said, okay, no, I will not use a direction drilling. I will correct my well by using a BHA. What the BHA is? BHA bottom hole assembly. Okay. So he can build a pendulum assembly like that. He put something like 30 or 90 foots. There is no any contact point except the bed, and put to stabilizer. That's one doing a pendulum effect. The pendulum effect is a negative force. What the negative force is tend to come with the gravity, and then if the inclination is a 3, this assembly will drop the inclination with RPM and weight on bit. That's what they are sometimes using the weight on bit, add weight on bit or reduce the weight on bit just to control the well bore trajectory. Now we call it pendulum effect. There is something called Forklum effect. What the Forklum effect? If I add a stabilizer at that point, stabilizer here, and I keep another stabilizer at that point, but this is one under gauge and this is full gauge, and add more weight, that guy will bend. This will overcome gravity and it will build inclination. That's why we call it Forklum effect. So the pendulum effect depend on the point of tangency. It's almost about 90 foot or no, 60 foot or two stands until you got the first contact point. So the bit and then stabilizer after that. That's when it will work in a soft formation or melt crooked hole country. Sometimes you have, as we said, Forklum effect, the Forklum effect. So the stabilizer of pendulum effect is at the top. The Forklum effect, the stabilizer will become here. The other one is negative. That's one is positive. You have a contact point very close to the bit. So what's the weight on bit? If you add the weight on bit here, that's a BHA will be doing like that. If the company man need to build from 1 to 6 degree, and he got a 0.5 degree per each stand for the whole well, he can do it by BHA. No need to run the BHA contain very precious on a very expensive tool like MWD, LWD, and RSS. So it's based on the Ferculum and pendulum, which is pendulum negative force coming with gravity. The Ferculum is a positive coming with its building angle. So there is some stuff like what we call it back hole assembly, or a lot of stabilizers. We have a backed hole, we have medium crooked back hole, we have a severe crooked hole. That's to hold inclination. You put more than one stabilizer, especially if the formation tendency is the building and you need to control the hole without any directional assembly. You run more than a stabilizer. That's one stabilizer, two stabilizer. If you take this guy and put it here, it's 3 stabilizer, what we call it backed assembly. This man, and this one stabilizer, 2, 3, and you have a bit and put it here. This is 5 almost, 1, 2, 3, 4 or 4. That's one severe. Sometimes we do it back to back stabilizer. We got this stabilizer, put it exactly like that. Like at that point, we call it backed assembly. Or why that? Because the tendency of the formation is a building formation. We need to avoid that. When we need to avoid that, to avoid doing an extra work while we drilling. Hydraulic and direction drilling, you need to understand the hydraulic optimal importance of the hydraulic. It's coming from optimal for flow rate. What the flow rate for hole cleaning? You need to manage the pressure loss to avoid excess pressure. Then you can damage downhole tool in addition to bump or rig bump. At the same time, hole cleaning, I will not go for here because that one is depend on the well trajectory, it depend on the well bore geometry, depend on the BHA, depend on the pressure drop through the bed, depend on the liner of the mud, depend on the rheology as well, the mud rheology, which is deformation versus time. I think that one it could be take 1 day, complete 1 day to continue the course of hydraulic. So the pump pressure, it's important to know that the standpipe pressure coming from service equipment, in addition to drill pipe, moreover motor plus MWD plus pit and annulus. A bit is important. I need more than 250 psi drop at the bit when I'm running the calculations of hydraulic. Why that? That because 250, that's one guaranteed to return 10 to 20% of drilling fluid for the bearing of the motor to cool down the motor while running. Otherwise, the bearing will burn out and then you will pull out of hole for no reason except the motor is failed. So that's one, you need to understand why we're doing bit hydraulics to select the motor itself. Sometimes we have standby pressure based on the rig type itself. It's rig type 1 or 2 or 3 or 4, then you can select the service equipment and you can put the factor for that to increase to come. Okay, some case hole service equipment specification. Number 1, case hole, the length of standpipe is 40 meter, outer diameter 3, length is 45, inner diameter is 2, length, and then you'll come up to the Kelly length itself. So that's one, there is a lot of software. It will ask you for the cases, what the case, what the rig case, what the service equipment specification. You tell number 1 or number 2 or number 3, he will take all that one, swivel, hose, standpipe, Kelly, and then it will give you the pressure made by that configuration. So anti-collision, important to know what the anti-collision is. The anti-collision is the distance, the safe distance between the offset and target well. We have a lot of calculation methods. That one of them is, we call it 3D close approach, and we have a traveling cylinder. We're using a traveling cylinder when we are nudging because we're doing a drilling tunnel based on the traveling cylinder. We have horizontal. I will not go for that in details. Why that? Because this is one, it will be with the course, it will take time really, and I'm not like to go through it right now because it's a day, a complete day to go for close approach, to understand the distance between well while I'm drilling, and that's one is very, very important. All companies right now ask you if you are completed the course of close approach or drilling safe, you need to do that. Otherwise, you cannot do as a direction driller until you understand what does it mean, the close approach or traveling cylinder, or the distance between or center to center and so on. So we have some clearance factor based on what? Based on radius of each well, radius well 1 and well 2, center to center. We have separation factor 1, less than 1, more than 1, you can start drilling. Separation factor equal 1, that's mean the ellipse of uncertainty for one well 1 is start the ellipse of uncertainty of well 2. Separation factor less than 1, you cannot drill at all. You're supposed to stop and raise the hand and ask them for exemption, and then they will give you exemption. Clearance factor, if it's more than 2, go ahead, you are safe. Less than that, you need to raise the hand and ask your manager or ask the company, please give me exemptions. I cannot drill, otherwise I can hit another well. Then if this is well still producing, you will be in a very bad situation. So drilling challenges, hole cleaning in high angle. If you have high angle wells, you need to look for cleaning strategy like tandem bell. What the tandem bell is, high vis, low vis. What the high vis? High vis is giving you what we call it laminar flow. But low vis, so we call it tandem bell, low viscosity, high viscosity bell. You bump that, the low viscosity will give you a turbulent flow. High viscosity it will give you laminar flow. So you are agitating the cotton bed on the low side of the well, and then the high vis is coming and swab all this is cutting out of the hole. Stuck pipe, we have a lot of stuck pipe scenarios happened while direction drill. One of them is the K-seat. We call it K-seat. What the K-seat is, when you have soft hard formation, if you have soft hard formation, that's one is the hard like limestone, and this is one is the soft like shale. Okay, and this is your hole, and you have what we have a tool joint of the well, and that string tends to do a pendulum with the gravity, so that tool joint it will doing another hole here. If you got cross section and that point, it will come in like that. When you pull out of hole, you can stuck at that point, so you need to avoid to make a K-seat. You need to avoid to do as well the dog leg, because the dog leg is changed in inclination and azimuth. You need to avoid to do that. Managing formation pressure as well. Formation pressure is a very big topic. If you have equivalent mud weight here, and we have a curve like this one, fracture gradient, or fracture pressure, if you wish. You have a bore pressure, that's bore pressure, and you have mud weight. And mud weight is supposed to be here. And you have what we call it shear failure equivalent mud weight. The shear failure equivalent, when the shear failure equivalent at that region, you are safe. You can drill here with under balance with no problem. Why that? Because you have a very good cohesion. You have a very strong rock. The rock is very compacted and the cohesive is very well. So when that come in that point between the bore pressure and mud weight window, that's also, it's okay. You can continue like that. But when the shear failure coming at that point, in this point, the shear failure very close to fracture pressure, then you'll stop here and ask them, guys, please, you can manage pressure while drilling. We need to manage because the mud weight, the fracture gradient very close to shear failure, so we cannot drill the well like that. So future trend of direction drilling, everybody right now using artificial intelligence and closed loop. Before we using RSS to continue doing the inclination and azimuth, and we cannot using it to put the tally book. Right now they use a full loop automation, so put the well, put the BHA there, and start send some commands to the tools, and the tools start doing a direction drilling, looking for depths, correct the depths, and so on. So they improve a bit the stability. What the stability is, previously we drilled the well in 3 months, 4 months. Now we drill the same well in the same area. In 20 days you can complete the well based on the bed technology. Technology of the bed depend on the cutter size, the type of tungsten material you are using, stability, you can steer or not. Previously we using the bed and looking for long and short gauge to avoid any erratic tool face while we are steering. Right now the stability of the bed is very, very good. Real-time decision support system, we have a lot of real-time what we call it RUC or RTUM or eyes or beacon, a lot of names. Just monitor what we have on the rig side in real time, then we can take the decision immediately and we can change what we need to change. That's what I need to tell you guys about the future trend and direction drilling. But still the direction drilling job is still giving a lot of money for the direction driller. You can do a very good money for your future. You can build your career in that one if you still need to be a direction driller. Thank you for your coming here. Some reference and further reading if you'd like to read more about the direction drilling. If you have any question, please me know. Please let me know.
Thank you, Dr. Ali, for this fruitful webinar. I really enjoyed it a lot. We will have like 2 minutes break until the attendees fill the feedback forms that I will send in the chat right now, and then we will back to receive the attendees' question in the chat.
Okay. Yeah, you can tell me the question because I don't know where is the chat itself. Okay.
Yeah, sure. I will tell you the question. So please fill in the feedback forms that I sent, and then we will receive your questions.
You still watching my screen or already stop sharing?
Yes, I'm still watching you.
I don't know. Wow.
Okay,
Okay.
I will stop it. I will stop. Do you want me to stop it?
As you wish. I have nothing special on my screen. You'd like to see it,
Okay,
fine.
maybe we will get a question asking about something in the slide, and you want to make a reference for it. So let's keep it for now.
Yeah, no issue, no issue.
Okay, let's receive the attendees question. We have the first question from Adam. He is asking if you could elaborate a little more about AI integration.
Okay, so Halliburton right now using something called Logix. That Logix is controlling the direction drilling from towers. Before we spend the days and night doing a set track. Right now they do it in no time. So that's one. And artificial intelligence, they using learning machines to do that. They learn their algorithms to do that. So each time they gain the knowledge and add that knowledge to the system, teaching the system to do their job that they are doing. It's called logics, and that one is um, brilliant. It's very good, really. I hope I understand your question, Adam.
Okay, we have a question from Zidane. Is the use of web stock necessary?
No, it's intermittent. I didn't hear you very well. Which ones? Trying Adam. Okay, and
Is it necessary to use the web stock?
the web stock, no, not really. Sometimes we are using a cement plug, but in the cement plug to do a side track, you need to be careful because some formation itself you cannot do a side track. But if you be able to use a cement, put the cement plug, wait cement for a while, and then tag the cement. After you tag the cement, you're supposed to use the drilling parameter, a normal drilling parameter, to drill few meters. If you got with a normal parameter between 20 to 25 feet per hour, that's good cement. Go ahead, stop, and do time drill to do a set track. Otherwise, you will go for WebStock.
Okay, great. So we have a question from Artem. So he was asking about the next course. Will we use a software for calculation or just we will calculate it manually?
I will calculate it manually because I would like to teach you how to do trajectory by your hand. And then after that, you can be able to use any software or you can build your software based on Excel. So in the market, there is a lot of software. Most famous one is the Compass. The other one, the Compass is a landmark software. The other one is the drilling office of Schlumberger. So both of them, they are using the same concept. I would like to show you how to use your hand to build your trajectory. Then you can use any software whatsoever, if it's a homegrown program like Excel, or in another way, if it's the
Mm.
yeah. Okay,
देखो क्या ये लग रहा है कुछ
hello,
sorry
Daniel, listen.
sorry
So we're still using I can teach you how to do the well bore trajectory using your hand. It's better, and then you can build your software by yourself. I did.
Okay, thank you. So any more questions? Okay, I think this is all for today. Thank you again, Dr. Ali, for this fruitful webinar, and thank you the attendees for attending. I will share with you now the coupon code of our flash discount. You will get 85% discount on all our recorded courses. So let me stop the recording first.